All right, so at the end of that example, we come back to this tutorial at a conference, a machine learning conference, sorry, in 2011 by Agarwal and Chen. And this is a Yahoo tutorial on the subject, so it's sort of interesting because Yahoo does this for real. And so they're going to tell you things which are of practical importance, whereas in this data-driven science, it's not so easy to determine what's important on abstract principles. Things can look very pretty mathematically or analytically, but not actually be relevant in the real world. So the goal is stated here rather broadly. We want to get the right item, whether the item be a book or a web page, to the user within the given context, what type of user they are and what time of day and etc. it is. And then we have to optimize the long-term business objective, which, as we mentioned earlier, last lecture, is not always trivial. Netflix always wants to optimize not movies looked at today, but retention of Netflix subscribers, because that's the long-term goal. If you remain a Netflix subscriber, they will continue to get money out of it. And there are various important core building blocks. Machine learning is this broad field that sort of either encompasses statistics or is a part of statistics, and they're all basically methodologies that take data and draw deductions. And we have multiple types of methodologies. So for offline models, these might take a long time to run and give you overall strategies, or they give you data samples that can be used for the second type of activity, which are online models, which is when I log in, my Google News has to be given to me in less than a second, or else I should get mad and go to some other news provider. Then we have optimizing many things. We've already pointed that out. We're optimizing user-related things and vendor-related things. And even the vendor has multiple people involved. An aggregator like Yahoo has many advertisers, and they have to decide which advertisers they are nice to and which pays them the most money. And so it's not sort of non-trivial. We either extract the user profile because the user enters it, or we just infer it from what the user does. More and more, we try to do things dynamically and do not want people to have to enter things by hand. There was an example earlier in the class of how eBay was able to use natural language processing to optimize the response to a certain query, because they were able to find out how people misspelt or creatively spelt various given item, and therefore help the user. So this is not really a recommender system, it is part of the overall ecosystem that goes into a recommender system. You need to make certain you interpret what the user types in the most precise fashion. Here's a Yahoo homepage, and we're trying to decide what to put on this homepage. That is sort of a key problem for Yahoo. And this homepage is divided into various areas. There are applications, news articles, search queries. These are the trending now section, and various feature articles which need to be recommended. And you need to decide what to recommend. And in doing that, you can also, there are various subtleties here, like on this packages at the top. You actually have many possible items you can put there. That's sort of the central place where the person's likely to focus after they've got scared by the octopus. And you have multiple things that can go there, and you dynamically can pick out of a sample. So you maybe pick the top 20 to 40, but only put on any one visit to the page 4 out of that pool, and you may of course rotate those 4 so people can watch and see if something better turns up. And of course, we route the traffic from this page to the other pages. And as we pointed out, this is and we have in more detail, it's actually the total revenue that counts, not the revenue immediately gotten from this page, because there aren't so many advertisements on this page, and maybe the most important revenue getting advertisements are on follow-up pages. So in order to decide how to do this optimization, we want to put in quite a lot of subtle things. For example, well, I'll give an example where we may actually increase the click-through rate, that's CTR, but that may actually lower our revenues because a lower click-through rate may be attached to going to sites where I tend to get bigger conversion. Because if one site gives me so much money from advertisements because the user that goes to that site converts, and namely they buy things from the advertisers at a certain level, but then the same user might more often go to a different page, but that page they don't convert as well as. So it's pretty important to look at the final result, not just the immediate click. And of course, all of this is coupled. We have those, remember we had that web page with multiple different areas on it. When we're trying to, simplest case is to optimize each area on its own, but in general, you want to optimize the areas together. So that's what it says here when we're optimizing our multiple modules, such as the trending now and the personal assistant and the news and the today module. You could do them independently, but maybe there are correlations, and so you want to optimize them together. So maybe, for instance, it could be that the simple separate optimization effectively puts the same information, the top information of that user, in two different modules, where I should do better to have one module focus on one area the user is interested in, and another module focus on a different area, because that will increase your click-through rate. Because if the modules are essentially giving the same, responding to the same interests of the users, then it's missing out on these other interests, which could be important. And as we pointed out, within a module, we have this difficulty that we actually want to optimize the final result, not the immediate click-through rate. So here's the sort of overall ecosystem. We have pages and ads and users clicking, and those users are converting the clicks in some fashion. And then we have advertisers bidding to put their information on the page, and all of these have to be put together in your machine learning and statistical model to decide what to put on the page. What you're trying to do is pretty simple. You're just trying to decide what items to put on the page for this particular user.